Okay, so let's continue with our next video in our Kafka Python tutorial series. And in this video, we will see more ksqlDB queries, that is the create table and create table as select. Along with that, we will see what are three types of queries in the ksqlDB, right? So till now, we have explored how to create a stream, how to query a structured data, right? Uh, how to use the explode function and how to create a stream as select. Similarly, like same to the create stream, we have the create table. Same to the create stream as select, basically creating a stream on top of a stream. Similarly, we have the create table as select, basically creating a table on top of a table. All right, so we will see and we will explore like what the difference between stream and table, because both looks same only. So our red panda is up, our ksqlDB server is up. So let's try to insert um, something into our topic. So topic has been created. So if I go here, so topic is there. So nothing is there, right? So let's try to insert. So user ID one, username something, user age something, and let's enter some information. 1234. Okay, so I have inserted the message. We can explore the messages here. Let me remove this filter. So message is there, right? So message is there, right? So we have the message here. So now we will create a stream. Not a stream, sorry, we will create a table. So open the docker execute -it. So if you do docker ps, you could see we have the case equal db cli, right? So we will do docker execute -it case equal db cli /bin/sh. So we will inside a ksql db CLI container, then we will run a ksql command. But to run a ksql command, we will first connect with the ksql db server, ksql db server 8088. So now we have connected with the ksql db server. So if you do show streams, we don't have any stream. Show topics, we should have one topic. Show tables, we don't have any table. So let's create a table. Create table users. All right. So if you go to the official documentation, here we have the create table. You can use create or replace table. Also, you can use if not exist. That is a different things. But we will simply creating a table. So let's create a table. So when we create a table, we need to give a primary key. Along with that, same when you created a stream, you have option, right? When you created a stream, you have the option. You can give the column names, or you can auto load the columns from the schema registry. Similarly, when you create a table, you have the option. Either you give the create table users, like give that like all the column names, or you can load the column from the schema registry, like here table with declared column. So you are manually uh, mentioning all the columns names, right? Here table with value columns loaded from the schema registry, right? So in our case as well, uh, we are going to load a columns from the schema registry, which is fine. But here we need to give a primary key. So if you search for the primary key, all right. So you must declare a primary key when you create a table on a Kafka topic, because if I will not mention, let's suppose if you create a table, create table users, same syntax, right? With Kafka topic is equal to test topic avro and value format is equal to avro. So if you simply do this, it will give you the error. The error says table requires a primary key. Please define the primary key. So I need to give a primary key. So I will give a create table users, and I will give a primary key. So let's see the syntax, because here if you see key type column, stream key, table as primary key, and here. So the bracket should be started. So bracket, so we will give ID, and in our case, our messages we are publishing as this. So what I want is key should be this one, the unique key, and this is of type text. So if you see, this is of type text. So same type you should give here. So it is a varchar, so I can give varchar. Let's suppose if my text is something else, uh, like integer, then I will give int or big int. All right, ID varchar, then primary key, and then I can give Kafka topic test topic avro value format is equal to avro, right? So you could see table has been created, and you can describe the tables. First we can show tables. So now you can see there's table describe users. So I think describe table users, describe users, I think spelling is wrong. Yeah, describe users. So we have like this columns ID, primary key, and then all the top level, we have the address, we have the basic info, we have the credited, we have the interest, we have the preference, we have the user ID, all the top level. All right, so we have that. But now if you notice, if I do select star from users, it will not going to work. If I click enter, it is not working, right? But when I created a stream and when I do select star from the stream name, it give me the output. So let me show you again. So when I did like select star from stream name, right? Select star from any stream name, it basically shows you the output, right? So here instead of the star, we are mentioning the column names. That is totally fine. But if you even if you give the star, it is going to give you the all the details. But when in case of a table, you are getting the error, and it is in the user table is not queryable. To derive a queryable table, you can do create table as select star from user. Basically, it is saying create a one more table on top of a table, same as when we create a stream on top of a stream, right? All right. So currently, when we created a table, nothing is there. So if you see, only we have one topic, test topic arrow, and in the consumer group as well, we don't have anything. But the table is created at the back end, right? But nothing is there, right? But one thing, if I do select star from users, emit changes, and if it hit enter, right? And now you could see as soon as I did emit changes, then I can see the details. But if I just do select star from user, then I could not see the details. But if I do select star from user emit changes, then I could see the all the detail. Let's enter one more ID, user ID is Patla. Let's put it age. Let's ID straight, and all right. and I have inserted the second message, and here you could see emit changes. Emit changes means show me in a real time basically it. So now you can question what is the difference between stream and the table, right? Because the same thing when we created a stream and when we do the emit changes, same thing we are able to see. Similarly, when we are doing select star from table name, emit changes, same thing we are able to see. Then what is the difference between stream and the table? All right, because this is also the row column, stream is also the row column. So when you have to create a stream, when you have to create a table. All right, so let me first solve this issue. All right, because currently in case of a stream, when we do select star from stream, we able to see the data. But in case of a table, we able to see the real-time data, but I could not see the select star from users. And which says you need to create a one more table based on top of another table. So let's see that. So let's create a table. Select, create table, create table. You can say query users, any name as select star from users. Now I have created a one more table. Basically, it's a query. So if you see, it has been created a query. And if I do show tables, it is showing you the one table which you have created, which is getting the data from this topic. And it is creating a one more table which is getting a data from another topic. But this table doesn't exist, right? This topic doesn't exist. So let's see whether this topic exists or not. So which means it automatically created a created a topic, and it has everything. All right, so now if I do select star from query users, I can see the data. But now notice one thing. So I have the user id 1, I have the user id 2. For user id 2 I have the name prince. For user id 1 I have the name sumanshu. And let me insert one more record with the same user id 1. But this time, instead of the name Sumanshu, I am giving something else name, but ID same. And let me give a something else and anything. All right. And now if I go here, if I do select star from query users, you could see instead of the three records, I am able to see only two records. All right. And for the user ID one, I am able to see only, sorry, I'm able to see the record with the name Nankana, but I could not able to see the record with the name Sumanshu. But in the topic, both the record exist. So if you go to the topic, so here uh, you have both the IDs 1 1, right? And if you go to the query users, it also has both the IDs, right? 1 1. But when I select from the table, it only show me the latest one. So that's the difference between table and the stream. So in the stream, it is going to show you everything, like all the logs. But in the table, it is only going to show you the latest value. But if you do emit changes, right? So emit changes, then it is going to show you everything. But eventually it is not storing, right? But when you are saying let's text from query user, then it is only going to show you the latest value. So as an example, so let's suppose you have the user's login, user one login, right? User one login. So a message has been logged, right? Now if you do select star from user table, it is showing you that user one has logged in. Now let's suppose the user upload some messages. Then the another message is user uploaded some messages, or user uploaded his profile picture. Now if you do select star from user table, then it is showing you the latest action which user has taken. That is the user has uploaded the profile picture. Now let's suppose user has did the sign out. So basically in the Kafka topic, third message has been published for the same users. That is the logged out or sign out. Now if you do select star from the users table or query users tables, then you will see, because it's the same user which is getting updated, so it is, you can say, because of the primary key concept or something like that, it is only going to show you the one data only. So here if you go to the table here, let's read that now. So create a new table with the specified columns and properties, right? Creating a table registering the underlying Kafka topic, yes. So you can SQL statement to perform operation like joins. Joins and aggregation we are not even seeing right now. We did not even cover in the stream. We are not covering to the like tables as well. Maybe in upcoming videos we will see. The table is backed by the topic, yes. Registering a table on a topic by using the create table statement is a distance from the create table as select. Yes, because create table is different, create table as select is different. Okay, this is something like everything is same, and here everything is same. So let me go to the documentation, create table. So we have did that, created a table. We have run one more command, show tables. I have show you, if you just do select star from the table, and this is not going to work. But if you do emit change, this is going to work. All right. So why this is? So, and hey, one second, there is one more thing, right? Create table as select. We already covered this query, right? Create table as select. So if you see, it is going to create a new materialized table view corresponding to the new Kafka sync topic. Similarly, when we created a create stream as select, it is basically creating a one more topic, right? So all the queries going into a one another topic. Similarly, this is a sync topic, right? Same for uh, same for here, it is going to the new topic. All right, so now let's go read this queries in ksqlDB, so that you should understand what is the difference between stream and the tables, and when to use what, when you use create stream, when you use create stream name as select star from stream name, when you create a table, when you create a table from a table. All right, but a basic, a basic like very small difference, hopefully it has been covered. In a stream you will able to see all the records, and stream is basically by the name stream, stream is a continuously fully of the data. Stream generally when used, when you have to do the real time information, you know, you want to know the real time information, right? So let's suppose you have some UI where you are showing something, some analytics kind of things, right? Some graphs, and you want to know as soon as some message has been published, a real time operation has been, real time the graph has been changed. So that's kind of a stream, that the real time. As soon as the message is updated, your balance has been updated, uh, something like that, right? It's a real time. But in a table, it's also a row column, but it will show you only the latest value, not all the previous, all the records, right? So now we have the three types of query: persistent, push, and pull queries. Even though we have covered all the threes, we run the persistent query, we run the push query, we run the pull queries. But now you can question, uh, we are running the normal query, select star from something, then which one is persistent, which one is pull, which one is push? So hopefully this will make you things clear. So persistent, so with the name persistent, persistent means when you are running some queries, right, the result is going to be stored somewhere in some topic, right? That is a persistent query. And if you remember, when we run create stream new stream as select star, basically creating a stream on top of another stream, then a new topic, a sync topic has been created, and all the queries which matching this criteria, all the messages going into that sync topic. If something is going into the sync topic, That means that is a persistent state. The data will remain always exist there, right? Similarly, when we run the create table, some table name as select star from table or some query, then you could see one automatically one topic has been created, right? And at the back end, whenever the query has been run, the data is going into that topic, right? So which means when you run this, when you created a stream in this way, or when you created a table in this way, so it is a stream, it is a table. I am doing select star from to show you the data, but if I even don't do this, if I normally insert anything, let me insert one more record. If I normally insert anything, so if I inserted anything, here you will see the data, right? Here you will see the data, which means query is running at the backend automatically because you run the query. And if you see that, let me show you. And now you say that how the queries are running automatically at the backend, because the query are in the running status. If you show you the queries, show queries, right? And if you see, we have a query users, and it is a type persistent. As I told you, we have three types of query. One is the persistent, one is the push, and one is the pull. So here you could see query users. This is some query ID which is automatically given that, but this is of type persistent and it is in running state. It is running state. So which means I just created a query. Alright. So when I create a table, even though command is create table and select from some another table. Similarly, create stream, select from another stream. All right, maybe I have the screenshot here. When I created a stream, let me show you. Not sure if I have the screenshot. No, I don't have the screenshot. But when I created a stream on top of another stream, it did not show me a message stream has been created. All right. Similarly, when I created a table, it showed me the create table. But when I normally created a table, but when I created a table on top of another table, then it did not show me I have created a table, but it show me I have created a query with some ID. With some ID, the ID is automatically allocated. And when it says the query has been created, automatically it's went into the running state until and unless you are not going to terminate that query, right? So if I do show queries, you could see this query is of type persistent, which we are covering under the three types of query. One is the persistent, and I told you persistent queries are those queries where we are running something like that, creating a stream on top of another stream, creating a query on top of the creating a table on top of the another table. Basically, these are not a stream, these are not a table, these are the queries. Because if you see the message, it says the query has been created, it doesn't say the table has been created, right? So these are the query and these are in the running stated, and it show the sync name is way because it says the persistent. So when you say persistent, so data should exist there. So where it exists, sync name, the query users. Okay, so where the topic, this table. What is the query? This is the query. Create table query users with this, the cleanup policies, compact retention period, replica, and this is the query. All right. If you want to terminate the query, then we have the command terminate, and then you can give the query ID. You can give the query ID, and if I hit enter, then the query has been terminated. Now, if you do show queries, you could see I could not see anything. So because the query has been terminated, earlier it was running, but now the query has been terminated. Now, if I insert anything, let me say insert ID is equal to 4343. All right. So message has been inserted. So if you go to the topics, the message inserted into this topic 434343, because the query has been terminated. So query is not running. So if the query is not running, nothing will go into my persistent topic. So if I refresh here, nothing is there. 4343 key is not there, right? Because the query is terminated. So we have the three types of query. One is the persistent. Persistent queries are those queries when you are creating a stream on top of a stream and you're creating a table on top of a table. So which is basically going to store your result in some Kafka topic in a persistent state. You can show the list of query using show query. They are the long running query. They will keep always running. And this can be stopped with terminate and the query ID. Now the push queries. So push query, we also see that, but now we are saying, okay, which one is the push, which one is the persistent, which one is of which type. We already run these queries because push means as soon as I am pushing something into my topic, right, it will show me. I don't need to pull here. When I run select star from users emit changes, right? So when I run this, right, so when I am running this, right, and if I enter anything, let me enter anything. I enter anything here, right? So as soon as I enter here anything, I could see the data here 500. So which means it is pushing, right? So this is a push query. My Kafka topic is pushing, right? So it's a push query. It is pushing here. So when I run the emit changes, it's come under the push queries. So if you see here, push queries, client gets real-time updates. So client has just run a query, okay, emit changes, and client is getting real-time updates, right? And the result of the push query is not persisted to a backing Kafka topic. It is not persisted because this is not a persistent query. If you say, I don't have any topic, this is a query user topic, this is for something else, uh, the result of that query is not persistent. This is just for maybe the analytical purpose. This is just to see the real time changes. Okay, what is going behind the scene, right? So that these are the push query because the client is not pulling the result, right? The client is not pulling the result. It is a push queries, all right? So it is a push query. So this is the topic. Topic is automatically pushing into the application. So let's suppose in my application, I just run a query, emit changes, and my application is running. As soon as something will come into the Kafka topic push the messages into the display in here display, right? Okay, so this is the push queries. Now the pull queries. Pull query means get the current value from a table. So when you say uh, select star from table, pull. So you are pulling something from a table, right? Get the current value point in time. So when I say current value, right? So current value means it should work on the table, right? Because if you do the stream will show you everything, right? But when you see the current value, what is the current state of the user, whether the user is still logged in, whether the user has been logged out, what is the current status? So that is the pull query because I am running some query, right? Select star from active user where user ID is something. I am pulling. That is the pull query. Only work on tables. This is not work on stream. Fast point lookup good for API. Returns only the current value. A pull query is a form of query issued by a client. All right. Same as database. Pull query is able you to fetch the current state of the materialized view. All right. So if you go here, so push query is a form of query issued by client that subscribe a result in change in real time. This is the real time. And this can be either stream or tables because emit changes is working on both. All right. And yeah, and this is not being persisted by a backing any Kafka topic, right? Okay. Now pull. So we are pulling. Okay. Find a car with number 4. Find a ride which is in Toronto. Locate a rider with A. We are pulling. Pull query is a form of query issued by a client that retrieves the result as of now. What is the current status? All right. So here, if you see, It's a normal SQL query. All right, pull queries enable you to fetch the current state of the material release view, because material was incremented update as a new event arrives. So this is the incremented update. Queries run the periodically low latency. Okay, so we have understand two concept here. So one is how to create a table, one is create table as select, right? And what is the difference between table and the stream? And now when we already explore all the queries, emit changes, create table name as select along with a normal, right? So we should know what are these categorized into three different types. Yes, they are categorized in three different types. So what are those three different types? So these are the three different types, right? So hopefully you understand at least something basic things, all right, rather than nothing. All right, so that's it. That's the end of the video, and thank you.